All right, greetings, scholars. Okay, so I'll check the waiting room again in like about 15 minutes for anybody that's coming late. I hope you all are doing well. So let's see. The main announcement for today is that I think the administration finally came to like a conclusion when it came to the discounts for my math lab, and so I was emailed like yesterday. The discount you can get full access to my math lab for 2 years for $100. And so to get this, basically just contact the bookstore, and they have the code and everything there. Okay, so that's the discount. Okay, so 2 years of access, full access to my math lab for $100. Okay. And so we're just going to kind of continue where we left off from last time. Let me check on you guys in Zoom one more time. Okay, a couple of more. Okay, that's good. I'm going to let this gentleman in. And so I know last time we were working on section 1.4, we made it about halfway through that section. So for the second half, we're going to rely on my pre-recorded lectures. And so that way today, we can go through as many of the corresponding homework questions for the section together as we can, right? So we're going to open up the assignment for section 1.4, and we're going to work here. Hey, Google, give me a random number between 1 and 23. Oh, now it says 13. I've been saying 13 all day, and it never said it. The closest it came earlier was like 14. Okay. So given this piecewise function, we're asked to find f of 1, f of 2, f of 8, and sketch the graph. Okay. So for instance, for part A, when x is 1, because 1 is less than 2, we're going to use line 2. And so that means if we're using line 2, the answer is always 2 in this case. Okay. So then when x is 2, that means we use line 1 because x is equal to 2. And so then it's like y equals x. So then that answer is going to be 2 as well. When x is 8, because 8 is bigger than 2, we're going to use line 1. So then the output is just x itself, which in this case is 8. Okay. And then the graph, now when x is less than 2, so to the left side of 2 is a horizontal line of y equals 2. And then to the right of 2 is going to be a diagonal line of y equals x. So it has to be either C or D. And I think it has to be C. We don't have any gaps or anything like that. So I'm going to go with C. Okay. As always, if anything is not clear, feel free to unmute yourself to ask questions. Otherwise, I'm just going to kind of power through. Hey, Google, give me a random number between 1 and 23.
2.
2. Let's look at 2. Write a linear function that has the indicated values and sketch the graph. Okay, so let's take some notes here. Let me zoom in just a little bit. Maybe not, because it's okay. Let me unplug this. That does affect it periodically. Man, I don't know about this like changing the weather. So did they officially not do like daylight savings time this year? Like did they? Because I thought it was like at the fall equinox, right? And we're past that. So I was like, you know, maybe they finally stopped changing the clocks, you know? I know it had been in talks for like some years now. Let me try this again. There we go. Let's zoom in just a little bit. That looks good. Let's Come on. Yeah, it's like, yeah. Can I revert? There we go. Let's try this again. Let's copy and delete. And paste. Okay. So we want a linear function with these values, right? So they give us two function values. Okay. I'm going to write these as ordered pairs. So when x is -1, the corresponding y is 3. When x is 4, the corresponding y is 13. So basically, they're asking us to find the equation of the line through these 2 points. Okay, so whenever we're working with lines, there are 3 formulas I recommend that you have ready to go. First is the slope formula. That's the rise over run, which is changing y over changing x. So that's going to be y2 minus y1 over x2 minus x1, okay? Again, this is the slope. We can also use the point slope formula. That's going to be y minus y1 equals m times x minus x1, okay? And then we have the slope intercept. That's the classic y equals mx plus b, okay? Also, I'm a fan of whenever we get ordered pairs like this to go ahead and label them x1, y1, x2, y2. So with this, it's a good idea to go ahead and find the slope, okay? So we said that's what, y2 minus y1 over x2 minus x1, okay? So what I did, I replaced each component with a blank set of parentheses, and then I'm going to plug in those components, right? My y2 is 13. My y1 is 3. My x2 is 4. x1 is -1. And the parentheses basically help us to keep track of our signs so we're less likely to make mistakes. On top, it looks like we get 10. On bottom, it looks like we get what, 5? So it looks like our slope is 2. Okay. So we have a slope. We could use point slope. I'm going to use the slope intercept, and I think I'm going to use that first point just because the number looks a little bit easier to work with. So then if I'm plugging it into y equals mx plus b, my slope is 2. I think my x was -1. We're trying to solve for b, and the corresponding y is 3. Okay. If we solve for b, we get b equals, so we add 2 to both sides, b equals 5. So our y-intercept is 5. So then if we put these concepts together, the equation of our line is going to be y equals 2x plus 5. Okay. We got 2x plus 5, or f of x equals 2x plus 5. So notice when x is -1, we get 3. When x is 4, it's the 8 plus 5 is 13. Okay. So we can be confident in 2x plus 5. So if the equation of our line is 2x plus 5, the y-intercept is 5 with a positive slope of 2, with the slope of +2. So it can't be A because it has a negative slope, and it can't be C. It has to be either B or D. We said the y-intercept was 5, so it can't be D because it has the wrong y-intercept. So by process of elimination, it has to be B. Hey, Google, give me a random number between 1 and 23. Hey, Siri, give me a random number between 1 and 23.
A random number between 1 and 23 is 4.
Okay, let's look at 4.
23.
All right. Sorry, you're too slow. Find the intervals over which the given function is increasing, decreasing, or constant. So with something like this, it's a good idea to look at the graph. One way to look at the graph, you can plot points. So choose several values of x, find their corresponding y's, and then plot the points and connect them with a smooth curve. You've seen me kind of do exercises or examples using my TI-83 Plus calculator. Suppose you don't have a graphing calculator, you can use this site called Desmos.com. It's free. You just go to Desmos.com. When you log in, when you go to this site, it looks like this. You just click on graphing calculator, and then it'll bring you here, right? So if we want to look at the graph, I'm just going to type in f of x equals a negative 2x to the power, hold on, before I do it. So a cubic function usually has an S shape and usually is increasing, but we have that negative leading coefficient, so it should be decreasing, right? So it's an S-shaped curve that should be decreasing. If I type in negative 2x to the power of 3, and you see the decreasing function there. Notice as we trace it left to right, it's always decreasing. And so the domain of this guy is going to be the very left to the very right, okay? And so the domain in this case is going to be all rails. So it's never increasing. Okay, it's decreasing over the all rails, and it's never constant. Okay. Hey, Google, give me a random number between 1 and 23.
Here's a random number, 13.
Okay, so let's do 14 since we already did 13. Given this piecewise function, find these properties. Let's see if we can use Desmos to look at this graph. So a piecewise function, all it is just multiple graphs on the same plane, but then you have restrictions. Okay, let me see if I can do this here. So, matter of fact, I'm not really sure. So what I'm going to do, I'm going to hop over to Google and I want to do a search for how to graph a piecewise function using Desmos. Okay. I just need to see one typed in. I can take it from there. Condition, y equals condition, condition colon value, condition. For example, y equals left. Let me look at this one. Okay. So curly bracket, condition value, condition value. Condition colon value, comma condition colon value. Okay, I think I got it. So using that example, if I mirror it, did I lose my other one? I thought I opened a tab. There it is. I want this one. Okay, so let's see if we can do this piecewise function. So we got f of x equals, we do curly brackets. I'm gonna do open and close. Condition, we got x is strictly less than 0, colon, 3 plus 3x. 3 plus 3x, comma, it's looking good. And then x is, I'm going to say greater than or equal to, yep, I got it, 0, colon, x squared, right? That's my first time doing this here. That looks pretty good. Okay, let's try to add some more features. So for that first line, we need an open circle when x is 0. So we want to plot the point 0, 3. But then how can I change the formatting? Label, drag. That's correct. I'm just trying to create an open circle. Let me, and I go to settings here, will that do it? More options. Okay, let me hop over here again. Let's go here. How to plot an open circle point decimals. Let's see. Plus, so I have a circle whose radius now. How do you make a point move? What are open circle? How do you write? What makes an open circle? Circles. How do I plot an open circle point in decimals? Close circle, click and long hold the color icon. Okay. Click and hold the color icon. So is it like this? Let me see what else it say. Just go away. Please go away. Stay signed out. Where did what I had before? I had something there. Plotting points. Undefined. I should have opened what I had before because now I can't find it. How do you make a point move? Open circle. How to plot an open circle. Maybe it was like the first thing. Click and long hold the color, the style menu. Let's open this up. Okay. Yeah, that's what I'm trying to get. How do we get that? You can also add multiple points. It's also possible to add points within the table. Style, show or hide the point. Yeah, where's that option? That's what I'm looking for. Okay, you know what? Maybe I need to change my screen. Let me go full screen. I think sometimes when you go full screen, it gives you like different options. Hmm. What else could I do? It's not there. Sure, hide. So we don't have that as an option. Change the position, change the size and angle. Okay, we don't automatically graph points at this. You can add an open point manually. Okay. Use a table to determine your point at this, then the graph on the point on a separate line. Yeah, how do, oh, okay, maybe if I remove A. Okay, let me try removing A. And then click and hold. Darn it. Points. See, yeah, we don't have, maybe if I change that to like 0.9. Let's change that to like 0.9. Enter. Yeah, we're not getting that option. Points. Drag. Let me turn drag off. Ah, there it is. I knew I could get it. Whew, that was an adventure. Okay, open circle. And let's make it a little bit thicker. Can we make it thicker? What if we do 2? Nope, that's way too small. What if we did 20? Let's go 12. Cool. And then we can just delete that, to be honest, right? That looks good. We got it. So we had to remove the label. That's what was throwing it off. Actually, and let's change this to like 1. Okay. So we got an open circle for the first one, and then I guess at the origin, let's do another. How do we do it? Let's plot the point 0, 0. And then actually that looks decent. I'll just do the same color. Matter of fact, we can go like this. Okay, so now we get something like this, right? So I went on and kind of like did it the way I did it so that you can see how to figure stuff out in Desmos, right? Because this essentially was my first time doing a piecewise function in Desmos, and you saw me as like, okay, if I wasn't sure how to do something, then I just Googled it. Let's slide over. And we were working here, right? Okay, so we got our image. We were able to like create points and things of that nature. So this is the graph, right? So when x is to the left of 0, it's the diagonal line 3 plus 3x. When x is greater than or equal to 0, to the right of 0, it's the right half of a parabola, right? So now if this is our graph, the domain is going to be the very left to the very right. So if we took this image and smushed it onto the x-axis, right, every x is going to be accounted for. There's no holes or gaps or breaks. So the domain in this case is going to be all reals. So this was more so a demo on how to use Desmos. The x-intercepts. So it looks like the origin, and when x is -1, what is that? Yeah, if x is -1, right, we get 0. So we get the origin and 0. Type in integer or simplify. Sorry, we get -1 and 0. So that's where it crosses the x-axis. Okay. The y-intercept, it crosses the y-axis once, because the image on the left where we have the straight line, that's an open circle, so it doesn't actually touch the x-axis. It gets really close, but it doesn't touch. So it only touches the x-axis at the origin. So the y-axis at the origin, so the y-intercept is going to be 0. Okay. And then we can essentially match up the graphs. It's not a, I think it's B. Yeah, let's just go with B. Okay, that was fun. And then the range, right? So the range is, if the domain is the very left to the very right, the range is the very bottom to the very top, right? So if we took this image and smushed it onto the y-axis, every y value is going to be accounted for. There's not going to be any holes or gaps or breaks. So the range is going to be all reals in this case. Okay. All right. So that was an adventure. But we got to the bottom of all. Hey Google, give me a random number between 1 and 23. About to go to Siri.
Here's a random number, 18.
Let's look at 18. Okay. The difference quotient. Yes, let's walk through this. So let me get a copy. I know this one gives students a hard time often. All right. Oh, come on. Paste. God bless me. All right. So difference quotient. So difference quotient, this is like a precursor to this concept in calculus called the derivative. The derivative is nothing but the slope of a tangent line at a point. And so what we do in calculus, we'll take this difference quotient, and what h is just some small change in x. So as this small change in x gets smaller and smaller and smaller, the difference quotient gives us a better and better approximation for the slope of a tangent line at a point, right? We're not going that far for our purposes. We just need to know how to do the algebra behind the difference quotient. Now, this is another form of the difference quotient. I know another way we'll see f of x plus h minus f of x over h. This is the same thing, it's just articulated a different way. Instead of saying some small change in x, you're saying a small change where you have the x1 between, a small change between x1 and x2, right? So that's what this is doing. So what we're gonna do here to find the difference quotient, we're gonna find each part. F of x is already given, so we don't need to find that. So let's go ahead and find f of a. And so for f of a, all we're gonna do is replace each x with a, okay? So first, let's replace each x with a blank set of parentheses. Okay, and then we said we want to find f of a, so we're gonna let a be 5. So we're gonna replace each x with a 5 and then get a result. 5 squared is 25 times 3 is 75, plus 5 is 80. Okay, so that's f of a. Okay, so we have f of x. So now let's just plug in the different components. So then f of x is what? So we're just going to do f of x minus f of a over x minus a. F of x is 3x squared plus x minus f of a is 80 over x minus a is 5. Okay. So maybe we can factor this numerator, okay? So we're looking for two numbers that multiply to give us 240, all right? I'm using this technique called the AC method. It's 240 because that leading coefficient is not a 1. So we say 3 times 80 to give us a negative 240. We're gonna go through all the factors of 240 and stop at the line that adds up to 1. Now we said what, 3 times 80. 80 is 8 times 10. right? So 15, oh, I think it's 15 and 16. I don't even think we really need to go through all of it. But suppose I didn't know it was 15 and 16. All right. So we can just go in order, right? First, we start with the combo -1 and 240. Do these multiply? Do these add up to give us 1? No. So we're gonna go to the next set. Now when we're gonna do -2. So then notice here, if we've used this -2 already, what's left over? 8 times 15 is 80 plus 40. I think that's like 120. So 2 and 120. But notice these do not add up to 1. So these are not the two numbers we're looking for. Okay, can we do 3? Yeah, we can do 3. All right. Notice, if we've used this 3 already, what's left over? You got 16 times 5. So that's 50 plus 30, which is 80. But these don't add up to 1 either. So these are not the two numbers we're looking for. Can we do 4? Yeah. Okay. If we've done 4, that means we've used these guys. What's left over? 15 times 4. That's 40 plus 20 is 60. These add up to 56. So these are not the two numbers we're looking for. I'm going to keep working over here. We can do 5. Let me clean it up. Okay. If we use this 5, what's left over? 16 times 3. 16 times 3. So that's 30 plus 18 is 48. So these are not the two numbers we're looking for. We're almost there. Can we do 6? Yeah, we can do 6. All right, because that's going to be these guys. If we've used these guys already, 8 times 5 is 40. But again, we're going to keep going until we get to the line that adds up to 1. Can we do 7? No, because there's no 7 in this. Can we do an 8? Yeah, we can do 8. Right? So if we've used 3 of the 2s already, what's left over? 15 times 2 is 30. But these don't add up to 1. Let's keep going. Can we do 9? No. Can we do 10? Yes. All right. So then 10 comes from the 5. We've already used the 5 and the 2. What's left over? 8 times 3 is 24. We're almost there, but these do not add up to 1, so we're going to keep going. Can we do 11? No. 12? Yes. We can do 12 because 12 is 4 times 3. So these have been used. We have 4 times 5, which is 20 left over. We're almost there, but these don't add up to 1. Can we do 13? No. 14? No. 15? Yeah, we can do 15. Okay, 15, we've used these two numbers. And we have 16 left over. And these are the two numbers that multiply to give us a -240 and add to give us a +1. So these are the two numbers that we were looking for, okay? So then what we're gonna do, I know some people like to use the box method. Once you have those two numbers, I'll showcase the box method for factoring. Kind of go like this. All right, so now that we have those two numbers, we can do this box method. I use this color, I guess. So the box method is something like this. In the upper left-hand corner goes your leading coefficient, which is the 3x squared. Bottom right is your constant, which is -80. And then on the other diagonal, you want to rewrite that middle term using the two numbers that you just found. So we're going to do our -15x and our +16x, okay? So now we're ready to factor. Okay. If we look at the two numbers on top, what can we factor out? What's the greatest common factor from the two on top? They both have what? 3x. What's the greatest common factor of the two on the bottom? Does 16 go evenly? Like, is that 5? Yeah. So you can factor out a 16 from both of those. Okay. What do the two on the left have in common? It looks like they both have just the x. And what do the two on the right have in common? Is it 15? What is that, a 6? 60 plus 30? No. Is it 5? 50? Is it 4? No. Is it 5? I think it might be a negative 5. All right. You're left with a 3 there. There's a 1 and the 30 is a 16. Yeah, so we can say negative 5. The greatest common factor with the 2 on the right is negative 5. Okay. So then our claim is that that numerator, I'll write it here, factors into 3x plus 16 times x minus 5. So the techniques, I use a couple of different techniques here. I use what's called the AC method of factoring, and then also the box method for factoring a trinomial. So factoring trinomials is something that, we do expect you to have some level of proficiency already. It should come out when you work in your lab, right? So factoring, that's one of those things, okay? So now we get some terms that cancel. This cancels this. And we're able to get it down to 3x plus 16. Let me see. Okay, we got 3x plus 16. Style. Okay, let's see. So we got 3x plus 16. Should it be an equation? Let's just do 3x plus 16. All right, let's do one more. Hey, Google, give me a random number between 1 and 23.
Here's a random number, 5.
Let's look at 5. Okay, so the table is a complete representation of f. Decide if f is even, odd, or neither. Okay, let me see if we see any patterns. So notice that whenever we have x comma y, we also have negative x comma negative y. So because both signs are changing, that's an indication that this is an odd function. All right, all the points should be symmetric and equidistant about the origin. But it's mainly because the signs on both numbers are changing. If the signs on just one number were changing, it would be an even function. And if it didn't fit either of those, then it would be neither. But let's see, this should be an odd function. Okay. All right, so we're gonna let that be. I think I'm gonna just go ahead and call it a day. So let's hop over here. Let me go ahead and make a copy of anything that you saw me writing. I'm gonna make a copy of it available. Are there any burning questions while I do this? Burning questions, okay. So when this bar finishes loading, you'll receive a copy of anything that you saw me writing. Also, may I encourage you all to maybe check my recordings from my earlier sessions with my other classes today. So either my 9 a.m., my 2 p.m., or my 3 p.m., because those are all College Algebra 1 as well, but we work different questions. It's the same section, but the same way we were jumping around with you all, I jumped around with them, and so I worked different questions. So if you want a more complete presentation, you can always watch those on my YouTube channel, okay, guys? All right, so if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. I'll see you next week, same time, same place. Take care. Peace. Okay, I'll mark him as excused. He was like extra late. Oh, you should have said something about my math lab. Oh, well, it's in the recording, so I don't think he's here anymore. Mr. Franklin, I just marked you as excused. So as long as you're not absent, then you should be fine. Okay. All right, gentlemen, have a good weekend.